So this is about to be part 2 for section 4.2, and I want to, before I jump into the concept of negative exponents, show you how negative exponents could come about in a problem. If I wrote a problem like x squared over x to the 5th, if I wanted to reduce that, there's at least 2 ways to reduce it. I could do this. I could write the problem without its exponents, writing 2x's being multiplied in the numerator and 5x's being multiplied in the denominator. And then I could cancel 2 of the x's in the denominator with both the x's in the numerator. And that's going to leave me 3x's being multiplied in the denominator, which I can write as x cubed. I'm not allowed to write a fraction without a numerator. If I cancel the entire numerator in my reduction, I leave a 1 behind. So x squared over x to the 5th is definitely equal to 1 over x cubed. If, because we're in this section, I said, oh, this is going to be a quotient rule because I'm dividing with like bases, I can simplify by subtracting exponents. And I can make this x to the 2 minus 5 power, and that's going to give me x to the negative 3 power. If I solve a problem using 2 different strategies, although my answers can look different, they have to equal to each other. So the answer that I got using the subtracting the exponent strategy and the answer that I got using the expanding and canceling strategy have to be equal to each other. In general, I say negative exponents usually simplify to a fraction. And negative exponents almost never simplify to a negative number. So with negative exponents, when I see them, I don't think negative numbers, I think fractions. I don't know that that's sufficient, but I didn't want to just plop the negative exponent rule on you without trying to give you some ideas of what negative exponents are and how they can come about. Negative exponents can come about by simplifying using the rule for subtracting exponents. So the negative exponent rule is exactly this. It says if I have a base to the negative, some negative exponent, to make the negative exponent positive, I could create a fraction that has a 1 in the numerator, and then I can take the base exponent combination and move it to the denominator, making the exponent positive. And this is exactly what I did for these 3 examples. When I have x to the negative 3, which is the example I showed on the last page, x to the negative 3 using this rule, I'll create a fraction with a 1 in the numerator, and I'll take the x to the negative 3, write it with a positive exponent in the denominator. Works for numbers as well as variables. 5 to the negative 2 power is 1 over 5 squared, and 5 squared is 25. So 5 to the negative 2 power would simplify to 1 over 25. One of the nice things about this calculator is it does fraction answers naturally. If I did 5 exponent, use the negative by the fraction and then 2, I see that it's 1 over 25. I don't see the intermediate step of 1 over 5 squared, but it gets me there. This is overcomplicating this problem, my answer, but it's the proper way to do this. So if I wanted to apply my negative exponent rule to the 6 times x to the negative 4, I really have to think of this as 6 times x to the negative 4, and even specifically maybe 6 to the first times x to the negative 4, because the negative exponent rule only applies to the base that the exponent is attached to. It doesn't apply to the coefficient. So when I did my work, I'm going to apply the negative exponent rule to the x to the negative 4th and make it 1 over x to the 4th. And I can't take that x to the 4th and write it to the right of a fraction. I can only sneak an x to the right of a fraction if the fraction doesn't have any adding and subtracting, and if the x is in the numerator. To write a final answer, that 6 I can think of as 6 over 1. And now I can multiply across the numerator and get 6 times 1, across the denominator and get 1 times x to the 4th, and that will lead me to that answer. There's another rule for negative exponents that we need to be familiar with, and this rule I'm maybe not going to write as an example because I think it's too complicated for right now. It maybe for some of you will tolerate it, but the rest of you it's going to be a waste of time. So let me just show you that the rule says that if we have a fraction with a negative exponent, we can make the negative exponent positive by taking the reciprocal of the fraction. So I have 2 separate fractions with negative exponents. I can make the negative exponent positive by using the strategy of taking the reciprocal of the fraction inside the parentheses and making the exponent positive outside the parentheses. Now the rules that we learned in part 1 of this video, if you have a parentheses with an exponent that doesn't have any adding or subtracting inside the parentheses, then I can attach the exponent to any number or variable that doesn't have an exponent, and I can multiply the exponent by any number or variable that has an exponent. So this would be 4 squared over x to the 6th, and then the 4 squared is 16. For this bottom version, if I have a fraction with a negative exponent, I could take the reciprocal of the fraction inside the parentheses, make the negative exponent positive outside the parentheses, then use the rule that we had from the last section that allows us to multiply the exponent for any variable or number that has an exponent written, and attach the exponent to any number or variable that has an implied exponent of 1 to avoid having to multiply 1 times 3, and then I'd get that for an answer. So I'm just going to use this negative exponent rule for problem 36. I'm just going to rewrite that as 1 over 2 cubed, and 2 cubed is 8. There's my negative exponent turning into a fraction. If I did 2 exponent negative 3, get 1/8. Generally don't leave numbers written with negative exponents. I don't generally leave anything written with negative exponents. I don't leave numbers written with exponents in general. So you want to, if you don't know the exponent, use your technology. 38, I'm just going to write as 1 over 2 to the 4th. And I know that 2 to the 4th is 16. So I'm going to write 38 as 1 over 16. 40, this is the third time I really like this problem for some reason. 40, I'm just going to rewrite as 1 over x cubed. Generally, we don't like to leave negative exponents written in our answer. Part of simplifying an algebraic expression is making negative exponents positive. (42), I'm just using the rule directly. B to the negative 4th is 1 over b to the 4th. I should be able to shortcut some of this. For 44, this is coefficient of 3 times the base exponent of x to the negative fourth. I'm going to use the rule to make the negative exponent positive, but that rule doesn't apply to the coefficient. So 3 times x to the negative fourth is the same as 3 times 1 over x to the fourth. And the 3, if I want to do the multiplication, I can write as a fraction. So this is the same as 3 over 1 times 1 over x to the fourth, which is going to be 3 times 1 over 1 times x to the fourth. And that's 3 over x to the fourth. This is ridiculous. I know how to go from here to there in my head. And if you can figure out a strategy to go from there to there in your head and avoid all that crud, be my guest and do it. I just want to show you the proper way to do it, even though I probably would never do the proper way. Let's just do 45. 45 properly, I would say this is 5 times 1 over y squared, making the negative exponent positive, but keeping the coefficient removed from that switch. Then I'm going to write the 5 as 5 over 1. I'm going to leave the fraction for the 1 over y squared, and then I'm going to multiply my fractions by multiplying across the numerator and across the denominator. And that's going to give me 5 over y squared. 48's off my screen, so I'll do 47. I could do 47 on my calculator. So left parentheses, fraction button, 2 over 3. Make sure to arrow out twice, I guess once. Arrow out to get out of the denominator. Right parentheses, exponent key, negative by the fraction, and then 2. That looks like the problem, so what I'm going to get is the answer. The answer is going to be 9/4. To get there without my calculator, I'm going to use the negative exponent rule for fractions. I'm going to take the reciprocal of the fraction, make the negative exponent positive, and then I'm going to use the rule from the first part of this and attach the exponent to the 3, attach the exponent to the 2, rather than writing exponents of 1 and saying this is 3 to the 1 times 2 over 2 to the 1 times 2. I skipped that step. And then 3 squared is 3 times 3, which is 9. 2 squared is 2 times 2, which is 4. Problem 50, I can rewrite as 4 over 3 squared, and then clear the parentheses by attaching the exponent twice. 4 squared is 16, 3 squared is 9. For 52, I can apply the rule. I have a negative exponent outside a fraction. Can make that negative exponent positive if I take the reciprocal of what's inside the fraction. And now I'm going to drag out that rule that we had from the first part of the video and multiply the exponents to clear the parentheses and get y to the 12th over x to the 6th. I'm sure I've made a mistake because I just naturally make mistakes and nobody's here to tell me. Usually I take the time to check every answer, but I didn't want this video to be that long, and I didn't think if I make a mistake it would be that hard to check, hard for you to find. So I'll do 54. I'm going to make the negative exponent positive by finding the reciprocal of my fraction. And now I'm going to attach the exponent to the y, multiply the exponents for the x, and get an answer of y cubed over x to the 9th. My 56 is too low on the screen. I'll do 55 with you. Same strategy for 55. If you have a parentheses with a negative exponent, you could invert the parenthesis, invert the fraction, make the exponent positive. Now this is going to be a triple attach. There's no exponent that's other than the implied ones. And for those, I just attach, attach, attach. I know that 3 squared is 9. I know that 2 squared is 4. And I know that x squared is x squared. Invert the fraction, make the exponent positive, and then properly attach or multiply to clear that parentheses, and then use technology or figure out what the power is equal to in your head. The next few problems, you can get an answer in multiple steps, or you can do it in a single step. There's a shortcut. I want to simplify these so that they only have one x, and I don't want negative exponents. So in problem 60, I'm going to use the rule that allows me to subtract exponents if I'm dividing terms with the same base. X to the 3 minus 7 would give me x to the negative 4. And x to the negative 4 can be written as 1 over x to the 4th. There is absolutely a way to go from there to there without doing the intermediate steps. And I, when I'm presented with a problem, like to do that shortcut. And this is a shortcut that's going to work every time. If you're dividing with positive exponents, if the larger exponent's in the denominator, you can skip this. What I could have done is switch the order of the subtraction and put the variable in the denominator. If you do the order of the subtraction in the way that it's presented, numerator minus denominator's exponent, then the letter belongs in the numerator. If you switch the order of what you're supposed to subtract, because I'm supposed to subtract 3 minus 7. If I switch the order of the subtraction and do it backwards, then I put the x in the backwards place. Instead of having it not in the denominator, I'm doing in the reverse world, I'll put it in the denominator. So that's the multiple ways to do this. You can pick the one that you like. They both will give me 1 over x to the 4th. It's not really a rule, but it's a technique that works. So for problem 62, I could just say this is y to the 1 minus 3 because the exponent in the numerator is an implied 1. That's doing the rule how it's written, not the reverse form of the rule. So this is going to give me y to the negative 2 power, and then I'll apply the negative exponent rule. If the bigger exponent is buried in the denominator of the fraction, I could do backward subtracting. Rather than subtracting the exponent in the numerator minus the exponent in the denominator, I could flip-flop. If I do the rule backwards, I have to put the letter in the denominator. Get the same answer. I like this reverse rule, but then that's learning a new rule. In problem 63 and 64, I need to treat this as two separate problems. I'm going to reduce the fraction 24 over 18, and I'm going to reduce the fraction y cubed over y to the 4th. I'll do it both ways. The fraction 24 over 18, I'm feeling lazy this morning, 24 over 18 reduces to 4/3. Regardless if I'm using the reverse strategy or the normal strategy, I can sneak the fraction of 4/3 in. The normal strategy, I would either, oh my gosh, I would either subtract the y, I would subtract the exponent and leave the y in the numerator, or I would subtract the exponent and leave the y written to the right of the fraction. When there's a single variable in the numerator of a fraction that has straight multiplication, these are equivalent, leaving the variable in the numerator or leaving the variable to the right of the fraction are equivalent to each other. This way gives me 4y to the negative 1 over 3. This way gives me 4 over 3 y to the negative 1. In the lovely backwards way, I'd leave the variable in the denominator and subtract the exponents backwards. The lovely backwards way gives me 4 over 3y to the first, which is the answer that I'm driving for. This backwards way I like because it avoids the negative exponent, but I have to remember, if I'm doing the subtraction of exponents in the order that I'm not supposed to, then I need to put the variable where I'm not supposed to. This strategy here, writing the y off to the right of the fraction, this now I can write as 4/3 over 1 over y to the first, make the negative exponent positive but not change the coefficient. Then I multiply the 4 and the 1, leave them in the numerator, multiply the 3 and the y, leave those in the denominator. Same answer. This one, I'm going to have to resort to this. I can't deal with that negative exponent in the numerator and get the answer that I want, so I'd need to spin the y off and make this 4/3 times 1 over y to the first. I don't need to write the exponent of 1. So 3 ways to get the same answer. This is the way that I would do, because it's learning something new, but boy, it's nice. For 66, I'm going to reduce the fraction 40 over 10. I can do that without my calculator, but 40 over 10 is 4. So the fraction part turns into the number 4. If I'm doing the normal way, I subtract the exponents normally and I don't have a fraction because the fraction went away. If I do the backwards way, I subtract the exponents and I need to create a fraction because I'm subtracting them backwards. And when I subtract backwards, the variable needs to go into the denominator. The backwards way takes me right to the answer of 4 over z to the 4th. The more proper way takes me to 4 times z to the negative 4 power, which is 4 times 1 over z to the 4th, which is 4 over 1 times 1 over z to the 4th, which is 4 over z to the 4th. I don't like the forward way, so I generally won't use it. And let me show you what I would do in problem 68 if I wanted to do this problem speed. The x's, I'm going to use the backwards rule because the bigger exponent's in the denominator. When I subtract backwards, I leave the variable in the denominator. The y's, the bigger exponents in the numerator, I'm going to use the forward rule. And when I use the rule how it's supposed to be written, subtract the exponent in the numerator minus the exponent in the denominator, then the variable either winds up in the numerator or, if you prefer, to the right of the fraction. So I backwards ruled, frontwards ruled, backwards rule in the denominator, frontwards rule in the numerator, or off to the right of the fraction. And for an answer, I'm going to get y to the 4th over x squared. One more and then we'll break for part 3. Let's do problem 69 together. And I'm going to laze it up. 69, backwards rule on the x. Big exponent minus small exponent, need to put it in the opposite level. Forward normal rule on the y, and I prefer it in the numerator when I'm going to have a denominator for a fraction. All right, a good time to pause, and we'll move into a part 3 and we'll end this section.